welcome to the stream. If you're new here, my name's Jared, and I write Ruby code, usually. I've been doing that for somewhere around 8 years, I think, professionally, and definitely fooled around with the language before that. These days I run a software consultancy called Supergood, where we build e-commerce websites. We use a Rails engine called Solidus to make that easier. It's extremely flexible, just like Ruby on Rails. Today, however, we're not doing anything related to e-commerce. We are instead working on Advent of Code problems. For the first 5 days, I did TCR, test commit revert, where every time I ran my tests, they passed, the test would be committed, and if or the changes would be committed, and if they failed, they would be thrown away. That was tough, kind of interesting, made me sort of reevaluate some things about how I was approaching test driving code, and I wrote a blog post about that you can check out over on jarednorman.ca. But we just sort of I decided that it was worth focusing more on the problems, because it was going to take me forever if I had to do sort of rigid test driving all of the code I wrote. So sort of backed off, using tests a little more pragmatically to sort of enable quick refactoring and that kind of thing. And sort of just verify our steps as we go. I took a couple nights off, Thursday and Friday this week. Came back with a stream earlier today where we got through day 11 and 12. So today we'll be doing 13. Along with day 13, as usual, I am doing a whiskey advent calendar. So this is the Anknock, I guess that's how you say that, I don't know. Peat Heart Batch 2. Another Scotch. Lots of interesting notes on the nose. Lots of interesting notes on the taste. It is. It almost tastes like, it almost smells like a wine. I'm not necessarily getting mango, but and yeah, I'm not sure I get the same taste. I can't get the finish though. It's really nice though. I would certainly drink that again. And so we are going to be doing day 13 in 5 minutes and 13 seconds. I don't have a lot to say for the next 5 minutes though. So if chat has any questions, anything, big thanks to Ignoble Solid, who was also doing a Advent of Code stream earlier today and rated us when we were done. That was fun. The streams have been fun. Been enjoying it. Nice that we've been getting at least a few people each time. I really do enjoy streaming code and working on sort of showing off working on things. So I'm gonna try and keep doing this. Favorite challenge so far. I really liked how I implemented the VM, and that's kind of an interesting one because I suspect we'll need to augment our VMs in the future. This is a thing they've done before. I don't know if they're going to do it again today, but adding additional rules and using the machine to compute new programs and stuff like that is certainly fun. I would love to do more of it this round, this year, if we get the chance. Other thing, we just got lots of fancy Supergood stickers. Look at that. Holographic thumbs up. And sort of the classic ones. And then got the same thing, but circles. Those ones are great. These are fun. These phrases appear in our branding. And then more thumbs ups. So if you would like me to mail you those, give me a shout on Twitter. I'll see what I can do. We just didn't do a huge run of these. There's our first round of these, but there'll always be more. All right, 3 minutes. Should we play with the lights in here? Try and make it even more Christmassy. Oh, that's the wrong Smart Things app. Type of challenge I'm hoping to see in the upcoming days? I don't know. What do I like? I really like any of these problems that I can sort of model as sort of like a sort of immutable construct that I manipulate and like use the fact that I'm sort of saving the state as I go to do something, sort of like with the VM and with the one with the ship. I definitely enjoyed that. Intriguing. That light lost its IP address, and I turned it off in hopes that it would rediscover itself. But now that it's done that, it looks very pink. Trying to make it red. Red and green. Maybe we go green on the top lights. Let's make the shelving green. And then we'll make the strip red. Yeah. That doesn't feel Christmassy to me, but that's what we got. Only 30 seconds till we start. Different vibe in here today. Prepare our editor. Worth noting, this will be done on Rosetta 2 on an Apple M1 MacBook Air that is sitting beside me is what I'm SSH'd into. So it's real zippy. Looks real good. All right, part 13 or day 13. Let's go. Let's go. Hello? Computer? Computer? Oh, uh-oh. Day 13, shuttle search. Your ferry can make it safely to a nearby port, but it won't get much further. When you call to book another ship, you discover that no ships embark from that port to your vacation island. Uh-oh. You'll need to get from the port to the nearest airport. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often that bus leaves for the airport. Uh-oh. Bus schedules are defined based on a timestamp that measures the number of minutes since some fixed reference point in the past. Timestamp 0, every bus simultaneously departed from the seaport. Very practical. After that, each bus travels to the airport, then various other locations, and finally returns to the seaport to repeat its journey forever. The time this loop takes a particular bus is also its ID number. The bus with ID 5 departs from the seaport at timestamps 0, 5, 10, 15, and so on. The bus with ID 11 departs at 0, 11, 22, 33, and so on. If you are there when the bus departs, you can ride that bus to the airport. Your notes consist of 2 lines. The first line is your estimate of the earliest timestamp you could depart on a bus. The second line lists the bus IDs that are in service according to the shuttle company. Entries that show X must be out of service, so you decide to ignore them. Not sure I entirely follow, but keep going. To save time once you arrive, your goal is to figure out the earliest bus you can take to the airport. There will be exactly one such bus. For example, suppose you have the following notes. Here, the earliest timestamp you could depart is 9:39, and the bus IDs in service are 7, 13, 59, 31, 19. Near timestamp 939, these bus IDs depart at the times marked D. What is the ID of the earliest bus you can take to the airport multiplied by the number of minutes you'll need to wait for that bus? Alright, alright. Take a little peek, see what we got. Let's make sure I understand this. First line is your estimate of the earliest timestamp you can depart on a bus. The second line lists the bus IDs that are in service according to the shuttle company. Okay. Generate day 13. Sure. Day equals input dot split on so the first one, we'll just take the first line, convert it to an integer to get the buses. We'll take the second line. We will split it on the commas. We'll map each one through to I, which will give us nil values for all of, no, it'll give us 0 values. With zeros, invalid. Can we just call that 0, or is that an active support thing? Split for nil class. I'm not worried about that. Cool. So that gives our list of buses and our list of days. Doesn't seem particularly difficult. I called this day for some reason. Timestamp. Timestamp. or at least time. So I think so let's, we got a sample here. So let's put that in there, and we expect the result. Oh, this is 939. Or sorry, not the 295 is the expected answer for part 1. Okay, okay. So kind of thinking we do buses. We map them to because I want to convert this to a hash because I need both fields. So all right. Where? Whoa. Sprayed water everywhere here. Perfect. So we want the first multiple of that number that's bigger than greater than or equal to the timestamp, right? So if we do, so if we have we have buses, or we're on bus 7, so this would be timestamp divided by bus. So let's do this. Big decimal? Whoop. Do I not have Ruby? Where's my big decimal at? One word big decimal? Ha. Okay, well, it still apparently doesn't exist. So we'll use floating point. It doesn't actually matter here. So a little bit of conditional logic to make this work. So we're going to say timestamp bus if and then we're going to return. So that's the number of times. So we're gonna net return x times bus if what am I trying to do here? What am I trying to do? I don't know why I was converting that into an F, into a floating point. So sort of two cases. If x times bus is timestamp, then return x times bus. Otherwise, we want x plus 1 times bus. That seems like a hacky way to do that. There's probably a clean way to do that, but and we want to return these as tuples so that we can convert them to a nice hash. But we didn't actually save that hash, so that's of no use to us. So let's do that. Excellent. There's no value in turning this into a hash. Is there like a so h.min by last, or I guess I want max by. Oh, I gotta multiply them anyway, so. The answer is just that. That's. Doesn't look right though. So, I produced a number that is approximately 2 orders of magnitude too big. Almost very nearly exactly. So that's interesting. What didn't I listen to in the instructions? Oh, I see. Okay, that's still not right. But this might be. No. What am I missing? So define the timestamp. Bus ID 59. So 59, I'm computing. Oh, I did want min by. Why did I taking the wrong result? So I'm getting 138, which is the right answer. So there we go. Day 13, part 1. Stumbled around there, we got to the answer. Part 2. The shuttle company is running a contest. 1 gold coin for anyone that can find the earliest timestamps such that the first bus ID departs at that time and each subsequent listed bus departs at that subsequent minute. The first line of your input is no longer relevant. For example, for this one, an X in the schedule means there's no constraint on what bus IDs must depart at that time. So this means you are looking for the earliest timestamp called T such that bus 7 departs at T, 13 departs 1 minute after T. There are no requirements on or restrictions on departures at 2 or 3 minutes after timestamp T. Bus ID 59 departs 4 minutes after timestamp T. There are no requirements or restrictions on. Okay. The only bus departures that matter are the listed bus IDs at their specific offsets from T. Those bus IDs can depart at other times, and other bus IDs can depart at those times. For example, because bus ID 19 must depart 7 minutes after the timestamp at which bus 7 departs, bus ID 7 will always also be departing with the bus ID 19 at 7 minutes after timestamp T. In this example, the earliest one is this. So example was the earliest timestamp such that all of the listed buses IDs depart at offsets matching their position in the list. Okay, yeah, we can do that. Seems fun. So this is our sample. Bring our input back down here. Okay. So I want to be able to return the buses. Okay, first of all, sadly, I need to write a new constructor. And need to switch key binding so that we are running on part 2 now. Now, we don't care about the timestamp at all, but we do not want to reject the zeros. Map. I'm just gonna do that. Valid.mining.pry here, and just make sure our buses okay, so at I don't care about variable names, buses dot reject. So just want the numbers in that variable, and then I want to be able to say what buses arrive, like check what buses arrive in a given slot. So we are going to, how do we want to do this? Z dot select bus, and if n divided by bus how do we want to do this? So we got, oh, we got to actually call buses. So n divided by, so divided by bus is not a thing. Excuse me. Oh, I see. Is that how we? Probably not. There's probably some more clever way. Trying to think if there's any like fancy, easy way to. Yeah. An array containing the quotient and modulus obtained by dividing them. Oh, maybe that's what we need. I mean, mine probably does the same thing, but Sure, we can use that. So it's bus or n div mod bus class equals 0. Seems reasonable. So if we say slot 0, should have all the buses in it. If we say slot 2, it'll be empty. So will 3, 7 will have the bus returning. 13 will have that bus returning. 14 will have the 7 returning. And it's an easy one. 62. I'm trying to lowest common denominator of those in my head, and that's not happening. They're common multiple. Now, there's endless ranges, right? So I can go like 0 dot dot. Cool. Let's use that. So we'll say 0 to infinity. We want the timestamp where this is the tricky part. So we want but we want steps in right? We can control steps. How do we do that? Ruby range. So we can do step buses first. I think we need like a data structure of these buses for what we expect. This is ugly, but we'll get there. So if we take buses, we need to buses each with index. Maybe that's all we need. It's going forever. So we say buses each with index. Or then we want to ensure that this block is true for all of these. This is a bus and an index, and we want to say slot dot x plus index so we want a next true if bus is not that. Otherwise we want to ensure that includes the slot includes our bus. It's not fast. Is it going to be something so big that I can't actually just search for it? Somebody's been doing this prologue or something and I've solved it like instantly. Or like some pattern matching language or something. I guess this is doing a lot of work that we don't need to do. So let's try and cool it. So slot bus. This is excessive. We never needed to do this. So this is n div mod bus last equals 0. Now we're still searching. It is one word, and let's move our pry. So this strategy works, but maybe the problem space is too big. I think we pinned the core. I'm just gonna do a quick little htop. According to this, I'm using 2.4% CPU with this process, which seems crazy to me since it's doing something CPU bound, right? Like what? Why do you think it's using so little? I don't understand how we could be using so little CPU, unless it's like throttling it or something. It isn't plugged into power, but well, we're gonna need to find a faster way to do it, because this is not gonna work. do this fast. Yeah, bigger than 10 million. Do we cheat and just skip the first 10 million? You think it would work? This is a bad strategy. I shouldn't be doing this. Why did it find the first one? How big? How fast is it going? Why isn't it not? Uh-oh. Stop. Why is it not? Stop. Starting at oh. Come on, calm down, calm down. Let's see. That's not the expected. So, let's grab the code exactly, actually. This is not what I expected, because buses first is 17. So like, does multiplication have higher do I just not know how things work? What? Oh, that's the remainder. Oh boy. But I can see that that's not gonna work. Though it is kind of a fun way to skip the start of this, but we got to be more clever, because there's no way this is a viable strategy. What do we do? Feeling a little stuck. Wish I could phone a friend, but I don't think that is fair. Wait, maybe I misunderstood this. just a bunch of additional tests. Maybe we should write those tests though. Because they're going to demonstrate how this doesn't work for, so like this test. Big number, so let's remove our silly hack. Oh, and I forgot to remove my put statements. But yeah, so you can see there's a bit of a delay on that one. So many bus IDs. Yeah. Where's Alstrat? Surely he should have a clever strategy for this. The smallest input where this is true. The fact that we want the smallest input in, one makes me really approach this iteratively, but this doesn't work great here. Try and make it more efficient, but I think the basic approach is just too slow. Maybe I need to take my glasses off. Maybe that's the trick. Glasses off. Another little sip of scotch. Brain wants to think of like more efficient ways of doing the thing I'm doing, and I'm not coming up with a way to make progress on this. Well, for fun, I'm gonna rewrite it as I'm gonna rewrite it a little bit and refactor it and see if that helps us think about it anyway. I kind of want to use lazy and then map do x. No, that's not going to do anything. I'm not actually changing anything about this. It probably doesn't even do anything. Oh, I gotta. Lazy's not gonna do anything there. It's already lazy. That didn't help me at all. Dang, I'm super stuck on this. Like, it has really straightforward properties, the thing we're looking for. In that, like, we're looking for something where, you know, the numbers are just multiples of other numbers, but boy, walk through this problem again. Oh, hey, how's it going? I'm super stuck on part 2 of Tomorrow's. I cannot think of how to do this efficiently. My current solution works, but it does not. It's going to take forever to finish. Guess I'll write it. I'm just gonna write it as sort of like straightforward math, to see if it'll help me. Each with index. Actually, map them. Each with index. So what I've here, I'll just re-explain it. Maybe it'll help me too. What I have, if you can ignore the first line for part 2, First line only applied to part 1. Basically, I am looking for the lowest number, which is a multiple of 17, which the number 1, 2, 3, 4, 5, 6, 7, 8, 11 after it is a multiple of 37, 12, 13, 14, 15, 16, 17 after it is multiple of 571, and so on through this list. I need the lowest number that satisfies that. It's a very big number. So while I can iteratively do that trivially, I have not come up with the way to do that in a way that will actually finish tonight, because the number is going to be bigger than whatever this is. Thousands, millions, 100 trillion or something. So 100 trillion, too big. Numbers that are bigger than that, too big to find iteratively. So now I'm thinking about what to do. Lowest common multiple of two numbers. Well, it's not their common multiples though. So I need the lowest number where the numbers, like, where I can find multiples of these other numbers this many after them. I guess is sort of how you say that. I don't know. So I'm just gonna write this. Yeah, you're looking for multiples 37 where 17 goes into that. Yeah. And so that's what I do. Like, I create an endless range that goes in steps of steps of whatever the first bus is, and it takes this. This is just a fancy way of looking up whether the condition holds true for increment 37 until x percent 17 equals 0. Or increment. Sorry, not quite. Increment 7. Sorry, not lowest multiple of 17 goes. No. So I'm looking for the lowest multiple of 17, where 17, or where that number plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is a multiple of 37, and so on for the rest of this list. So it's like, because this is a timestamp. So the idea is that each of these are the frequency at which buses are arriving, and at a timestamp I want a multiple of 17, and then at a certain timestamp after it I want a multiple of 37, and at the specified timestamp after that I want a multiple of 571. Yeah, exactly. So I was just trying to clean this up to simplify it a bit. So I'll split that. I'm going to do each with index map. Yeah, essentially. I'm looking for that X. Find out x is given the lowest possible value. Not sure I follow. So go back to the puzzle here. Shuttle company is running a contest. 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID departs at the time, at that time, and each subsequent listed bus ID departs at that subsequent minute. So with this one, we expect a 7 to depart, and then a minute later a 13 to depart. Then we don't care about the minute after that or the minute after that, and then we expect a 59 to depart, and then we don't care the minute after that, and then a 31. Yes, the bus IDs are also the frequency at which they depart. Yeah. Yeah, it's tough. It's tough if you miss the first part. There's a bunch of lots of setup for this one. Yeah. Yeah, 7 departs every 7 minutes. 13 departs every 13 minutes, so on. I'm writing some really ugly code here, but can remove that. So we can first populate the rest of the x's in the list with the existing departures. We don't care what the x's are, and we don't even care. So even in the example, here this part's important. The only bus departures that matter are the listed bus IDs at their specific offsets from T. Those bus IDs can depart at other times, and other bus IDs can depart at those times. So we really only care that we find one where a 7 and in the example here, a 7 departs here. A bunch of other things could depart also at that time. Doesn't matter to us as long as the 7 does. Same with here. We need a minute later, a 13 to depart. Doesn't matter if other things do. We don't care at all what buses are departing in these slots. Then we need a 59. Don't care what else might depart in that slot, et cetera, et cetera. I think I did a different transform here. Let's make sure I did it right. So buses now should contain bus IDs followed by the offsets we expect them to find them at. My solution's gonna be totally broken now though, but that's fine. We can simplify this. This is now bus's first dot first, because we want the first bus's ID, because they're now tuples of their IDs and their offsets. And we want buses dot all to, and we're going to pass in the bus and the offset. We don't no longer need this. We can reuse this logic up here. Say x plus offset div mod bus equals 0. Yeah. So this is like the simplest way I can express this, and I think that'll pass our tests. Yeah, that passes our tests. So it runs through the couple of the examples we gave us and establishes that that's correct, but sadly puts x if x forgotten how to type percent symbols. I guess we don't need to do the full div mod. We can just do percent. So that's like pretty fast, but like not computing 100 trillion fast. Like, I don't know, maybe you could do that in C or something, but or in a macro-based pattern matching language probably might be able to do this fast. Write some Clojure or something. I don't really know Clojure, so we definitely wouldn't finish that tonight if we were doing Clojure. Anyone else in the chat got any suggestions? Yeah, do it in Elixir. As much as I enjoy Elixir, I kind of committed to the Ruby thing. I'd have to get Elixir running on this M1 MacBook too. I'm sure it probably runs fine. All's short circuiting and everything, so that's not a big deal. What to do? Oh, wait. So ooh, I got some. So when you what if we extend the logic that we're using to know that we should go in steps of whatever the first bus is to subsequent buses once we find multiples of them that match. So once we know where the first two conditions are met, we know what we know something. We know how many we can move in bigger steps, right? So if we find a multiple of 17 with a multiple of 37 11 slots after it, then we can move in multiples of whatever we're at now. I think. Does that make sense? So every time we find another digit, we can move in bigger jumps. Yes. This makes sense to me. If this doesn't work, then I'm gonna call it for tonight and maybe try and grab a hint from one of my friends who might have finished this already. Okay. This is going to be a weird solution, but so we start with step equals buses.first.first, and the index we're on is going to start with 0. Don't know what our loop looks like. So next bus, or I think we can even just do this as a loop over buses. Buses step equals 0, index equals 0. Buses dot each do, and this is a bus and an index. Oh, we need separate. Let's call that on n, or we'll call this one. This is an offset, not an index. Okay, I think we can do this. Step equals bus. That's the bus ID, or the bus frequency. I like tonight's scotch. Until index plus offset divides evenly by bus. Index plus equals step. And then we return index at the end. Oh, and I need a I didn't. This isn't working. That's infinite looping. So step initially is equal to 7 the first time we entered the loop. This is just testing the example. Index plus offset is 0. 0%7 is going to be 0. So that's never going to execute. Then we're going to get to the next one. Step is now set to 13. Index is 0. Bus. Do we ever hit the next one? Oh, okay, I know one thing that's wrong about this. I'm supposed to be setting step afterwards. Okay, didn't work. This approach is not working. Ooh, we got some more viewers. Welcome more viewers. We're working on Advent of Code Day 13, Part 2. trying to come up with a clever way to move more quickly through the problem space, because I haven't been able to come up with a really like quick solution that doesn't involve just searching, since we are just looking for a minimum. My current strategy is attempting to move by bigger increments. Must be thinking about this wrong now. Oh, and goodbye, new viewers that we so briefly had. Okay, so index plus offset percent bus equals 0. So for each bus, we keep moving quicker until we find it. So the first bus we find immediately. Found multiple of bus at index fails tests and produces a result which is vastly too small. So am I just totally wrong about this one? I'm probably not thinking about this right. So if we find a multiple of 7 where I'm not setting this is wrong. This should be, so I'm not setting the step to the right thing. The step should be set to the current index. No. Something more like that though. Dang. So let's just try and step our way through a simple one then. Say it was 3, 5. 30 or something. I might need to make it smaller to make this doable in my head anyway. So I just made an infinite loop anyway. Because index is going to be 0 for the first one. Nope. I'm just trying numbers. Obviously, I'm getting tired today. Might have to give up and revisit this. Dang it. I mean, that produces a conceivably correct number, but it didn't pass our tests. Did it pass any of our tests? No, it did not pass our first test. What do you think? If we just stumble on a solution that only works for our for our input? No. Answer is too low. Okay, good. It was a long shot. I had to do it for the laughs just in case. What's the earliest timestamp I can depart? Well, it doesn't apply to part 2. But it was like that number. That's only part of part 1 though. Oh, the 939 is what I'm using in the test data. That's just what they used in the example. Yeah. The 7 bus comes every 7 minutes. The 13 bus comes every 13 minutes, and so on and so forth. Also, hello, Sean. Welcome to the channel. So my thought was, once we find a spot where there's a, say using this example, once we find a spot where there's 7, a timestamp that's a multiple of 7, that has a multiple of 13 after it, we should be able to jump in multiples of whatever this index is, because we should know, right, that like both these numbers, like this number times 2 and this index times 2 are still going to be multiples of 7 and 13, right? So if we just double them, we're still going to hit another multiple of 7 and 13. And if it's the lowest multiple of 7 and 13 that we found, then it's the smallest increment that we can move to find another pair of multiples of 7 and 13. And so we just have to test the subsequent ones till we find that and keep going. So I think my logic is good. I think this is the clever trick we're supposed to find. But boy, very tricky. I must have something off. Seeing it. Yeah, I mean, I think this is the clever math. I think I must have just not implemented it correctly, and it's just tough to debug. It's a very tricky sequence. solution, how many steps should 13 be away from 7, or do you know? In the example, 1. Like, it should be, we're looking for the timestamp that's a multiple of 7, where that timestamp plus 1 is a multiple of 13. We don't care about that timestamp plus 2 or plus 3, but then plus 4 must be a multiple of 59. Don't care about the one after that, etc., etc. Except that our actual input is huge. So we find a multiple, just is a multiple of 37. So these are finding, oh, that backwards. Yeah, those are all good. We're blowing by a valid solution though. We're at index. We know index is a multiple of index. Like, so we move in multiples of that. Then we find 78. Why are we checking 154? That's not the right number. Or should I be, oh, I guess it's useful to do that. Go to our example here, try and step through it. So we find a multiple of 13 at 78. Presumably that's correct. But then what is going on? What am I missing here about these numbers? Okay, it's probably the offset. We're just getting confused by the offset going up. Index, offset, index plus offset. Just make it a little easier to, oh, those are gonna, so 14. So we find a multiple of 13 at 78, which is 77 plus 1, then 77 times 2 plus our new offset of 4. Okay, that all tracks. That makes sense to me. guess my logic's maybe not good. Dang. I am stuck. Maybe my logic's not good. We had 1, 2, 3 or something. We'd check 2. No, that's a bad one. 2, 6. Check 0. 0 is not. 0 does not have a multiple of 6 after it, so that's fine. Then we check 2. 2 does not have a multiple of 6 after it. Then we check 4. 4 does not have a multiple of 6 after it. Check 6. 6 does not have a multiple of 6 after it. And so on. We hit 10. Then we'd be like, ah, yes, this is good. So let's say we were looking for multiple of, I don't know. All right, I'm gonna call it there. We do not have a solution. I need to go to bed soon, so I will revisit this and try and come up with a solution. Maybe steal a couple hints from someone I know on how to get this one over the finish line. But thank you everyone for coming and hanging out. I do this every 9 p.m. Pacific. Follow me on Twitter if you don't already. Super Good Jared, or follow me on here. Also Super Good Jared. Peace.